Therefore, I would like to hand over the session to Miss Anati, who will guide us through the topics today. The floor is yours.
Thank you very much, Ms. Nadia Sulaiman. So, good day, good evening to all of us. So, for today, I'll be starting the session, and then the follow up will be with Ms. Sushan, and then we'll have at the end the grand finale to Imran. Okay, so without further ado, let me share my screen to be able to start the session. Ladies and gentlemen, let's start our session. Data Analytics and AI Monetization Journey. First of all, I would like to thank you all for joining us for the session today, and hopefully we'll have a great session ahead. All right, let's talk about data analytics and AI monetization journey. The keyword journey. All right. So being a journey, we have our start point and then we have our end point where we want to achieve our destination, right? But before we can go towards our destination, we need to understand the high level understanding of how the data can lead to monetization. All right. Let's start our session with this first graph. From data to decision. These decisions are the one that can allow us to make monetization, right? So let me take you on a journey where the raw data transforms into decision that shape the business. First of all, it will always start with the data creation. As you can see in the graph, the data creation part is on the left side. That is the number one part. Why? Because without data creation, we will not have the decision. We are moving forward from the previous decision-making strategy. Previous decision-making strategy revolved around people brainstorming and finding the best strategy based on our previous experiences, based on what we as humans gather the experience that we have. But when it comes to fourth industrial revolution, we have data-driven decisions. These data-driven decisions actually empower us. Why? Because as human, we have our own limitation. Our limitation is that we cannot handle the big amount of data, or what we call it these days, big data. We to be able to analyze all of the big amount of data, we will need technology to come in handy. That's where we have the data-driven analytics. All right. So we start with the data creation. Data, where is it coming from? So let's imagine in a factory, for example, you can, every time the machine is running, every time the sensor is beeping, every time a customer make a transaction, and then every time, let's say we post on social media, all of those are considered as data creation. Every single thing that is happening, as long as it's connected to the internet, all the data are being collected. So yes, somewhere everywhere in our phones, in our emails, our apps, our locations, our even car these days. Every interaction, every movement that we make these days are generating data on its own. So we're not only talking about data in a factory, we are also talking about data individually we as human produce from day to day. So data is being created by everyone, everywhere. So that's the first part, data creation. Now, what do we do with this data? What happens next? We have all of this data coming from everywhere. So where does it go? So that's where we go for the data acquisition. All right. You can see the graph. Data acquisition is where the engineers will step in. This is where the raw data, whatever data that we get earlier, we consider it as a raw data. Data that has not been processed yet, that has not been analyzed yet. So it has a bunch of data getting stored and organized. What we can imagine it as a massive library. So all of the data are coming from thousands of sources, different sources that are being placed neatly into different sections in a library. So we are no longer using basic storage system. Back then, we may use Excel, but these days, Excel will not be able to handle the big amount of data that we have. To do that, we will use cloud computing, Hadoop, and some high-speed networks. So all of these new technologies will enable us to handle the data acquisition. So we got all the data, we already store the data, we already arrange the data. So what's next? We cannot simply jump to analytics at this point. Why? Because when it comes to analytics, we have different types of analytics. We can have the same data being analyzed in multiple different ways. You have the same data, but different departments are analyzing the data and interpreting it based on what they need. Different departments have their own needs based on the same data. So, how do we make sure that this data can accommodate all of those needs within the business? Okay, so this is where we are going into the data streaming. So basically, we are processing the information. We are processing the information to be able to access for the next part. So in this information processing is where the analytics will do its magic. So the vast ocean of data that we have, we will be able to uncover the insights because data are just data. Raw data does not give us any information on what we need to do. We need to analyze them first. We need to build models. We need to forecast the trends. We need to explore the data to be able to give us the insights that we need. The what, the why, the what's next, what we can do with the data that we have. So that's the information processing part. So once we have this kind of information processing, we can have the deep insights, we can have the real-time events. So real-time events comes from real-time data. Real-time data means that the moment the data is being collected, that is the same moment that the data is being processed and also analyzed. Within seconds, it is considered real time. Otherwise, it is historical data. We'll explore that further later. Next part, which is the business process. So this business process is the part where the insights that we have, the information that we have now can meet the reality. So in this reality is where we can use those decisions that will affect our business and affect the monetization of our business. Let's imagine something simple. Let's imagine a company running on a smart system. So this smart system involves advanced analytics. Advanced analytics can predict what the customer wants before they are even asking for it. So before customer comes in with a request, they can already predict what are the trends, what are the current need customer. So the company can be better prepared to achieve what the customer goals are. Okay. Or we can also imagine a location-based services that can send personalized offers. So this personalization will lead to the customer being more attracted towards the business that we are providing. So all these businesses are using these insights to make decisions that will enhance the customer experience and the overall operational efficiency. Ultimately, this will lead to the monetization. So let's talk more about data and analytics. Okay. So when it comes to data analytics, currently we are in the advanced phase, but this is not the stopping point. We have further advance coming, chasing us. These technologies are chasing us with new development. But before that, let's look into the previous historical evolution of these analytics. So back then, the only analytics that we have are considered as descriptive analytics, reporting. So we are reporting what happened previously, maybe 1 month ago, 3 months ago, maybe 1 year ago. So all these data are all historical data. So they are not real time mainly. And then the process to be able to extract the insight and create the analytic is difficult back then. So traditionally, it was manual. All this processing information, all of it are manual. Now we have the big data. Okay, after the traditional, we have the big data. So in terms of big data, we have a lot more complex, large, unstructured data. So we can imagine that in the traditional business intelligence, what we do is there's limitation to what we can analyze. We can analyze up until 3 months, we can analyze until 1 year, but that's all the limitation in terms of how many data we can use. But when it comes to big data, the era of big data, we have countless millions, trillions amounts of data that is coming in and we can better analyze. Why? Because when we have more data, meaning we have more information, it can be 5 years, it can be 10 years worth of data, this data will enable us to have better informed decision compared to just a 3 months data. So this big and large data is considered a big data environment where it will require a different technology, which we will get into later, compared to the previous business intelligence. Also, big data comes into play with the real-time part. So this real-time analytics is where we have the real-time data coming in, not just the 10 years historical, but also the real-time data that is affecting our real-time decision. So the decision and analytics are a lot quicker than before. But again, we do not stop. We have reached the age where we are not only talking about real time, like we're not talking about the present, we're not talking about the past, but we are talking about the future. So when we look into future, we call it advanced analytics, where we are using technology to predict what will be the future data and how we can act based on the future analytics. So we're not talking about now, we are basically projecting and forecasting into the future. Let's look into that one. Here are the different types of analytics. So when we talk about analytics, the graph that we usually see, making graph, I believe all of us are majority familiar with Excel graph, or you can use any other tool to create a graph, but those graphs are essentially descriptive analytics. Most of the time when we look at graph, it is descriptive analytics, where it is a historical data. So we start back then. We have the transactional reporting. So transactional reporting, the spreadsheet reporting, just the Excel. So manual data integration, we add the data manually into the Excel. We keep in such and such. I believe, unfortunately, a lot in Malaysia are still in within that system of transactional reporting. We also move to data warehousing. So all these transactional reporting, you can imagine how many Excel that they have to handle, right? And then we have the data warehousing where all of these are centralized data. So you can imagine a warehouse, a big warehouse that has all of the data. So not now the data are no longer segregated, they are in a data warehousing. So you only have a single source of truth. Regardless of how many departments you got one single source of truth where the data is coming from one place. Better for the data integrity as well as to ensure that the data all are updated. So that is data warehousing. From the data warehousing, so the amount of data that we have the descriptive analytics. So we describe what has been happening, what is the data showing to us. And then we move on to the next, which is advanced analytics, the predictive analytics. So predictive analytics is when we forecast what will happen in the next 3 months, in the next one month, or even 1 year. So based on the historical data, we can use technology, analyze and pick up the pattern. Because as human, we are really good at picking up patterns for sure. But we have our limitations because we cannot be able to analyze 10 years worth of data. Our capability of the mind are limited in that way. But that's why we have the artificial intelligence or artificial brain that is assisting us. They are able to analyze all of these data and then predict. Based on the patterns recognized, they can predict what will be the future data. So let's say our sales is a certain number at this month and a certain number, for example, currently is in September. What usually happen in October for the past 10 years? What usually happened in all the October of 2023, 2022, even before COVID? So what are the trends in October? So based on those patterns, we can predict what will happen in October of 2024. That is the prediction. What will happen to our sale? Is it going down? Is it going up? And the most advanced one that we have is the prescriptive analytics. So we need to differ the two. Predictive analytics, where we just predict, let's see what will happen, and prescriptive. Prescriptive is the most advanced where it will allow us, it will become an advisor to us. Because we're talking about data-driven decision, right? When we talk about predictive, we look at the data, all those analytics, and we will make a decision. Prescriptive analytics, what it will do is, you can imagine a doctor, they prescribe us a medication, right? So in this case, the analytics will prescribe us what will be the best scenario, what will be the best course of action in order to mitigate whatever risk that we have predicted. So we imagine that when we predict something, oh, we predict that the sale is going down. Okay, what now? We need to have strategy in order to mitigate that risk. What's the point of predicting if you're not going to do something about it, right? So that's why we have the prescriptive analytics. It's an advanced analytics where it will suggest to us how we can mitigate the risk, how we can avoid the certain situation, what will happen if we implement a certain strategy. So all of these are under prescriptive analytics, where we want to remedy the situation before it can happen. So, this way it will avoid a lot of different risks for us. So this kind of prescription given will allow us to react much faster towards the current events based on the real-time data that we have. Right. So these are the analytics that we have discussed. I would like to add one more with this group. Okay, we've talked about descriptive, we've talked about predictive and prescriptive. Let's talk about diagnostic. Okay, so diagnostic is a between descriptive and predictive. Before we can predict anything, let's diagnose what we have. Usually, when we create a graph, everyone can create a graph. Honestly, it's the simplest form of graph. Everyone can do it. But how we can interpret the graph, how we can make the graph more meaningful. Does the graph tell us a story of what the data is telling us what we should do about the data, what the data is advising us, what patterns can we see. So those are all diagnostics. So for example, we can see in the descriptive data that we have a problem with sale in the month of October. But diagnostic will go deeper into it to see why exactly are we losing sales in the month of October. So in diagnostic, we talk about RCA, root cause analysis, where we will go through what is the root of this problem. Because the only way for us to be able to mitigate the risk and to be able to solve the problem is to go to the root. Because everything else is just symptom. All of the analytics, the sales going down, the turnover rate is going high, all of those are symptoms towards an actual problem. So for us to be able to remedy that, we need to know what is the exact cause. That's why we ask the question of why. Why this data is showing like this? Why this data is happening? And why up until we get to the root cause where we will be able to know what exactly is causing the problem. In that way, we can do a targeted remedy. So we are not just randomly trying to fix the situation. We go focus based. When we go focus based, then the actions will show a better result compared to just a general solution. So that is an important part of analytics. It cannot be left out. We must be able to diagnose. That is part of the data literacy that we are advocating. When it comes to data literacy, everyone knows their data, but do they know how to interpret their data? Or do they know how to build a story out of the data? So those are the important parts. So once we have all of this, then we will be able to monetize the data. Let's talk a bit deeper into how this analytics work. Because, yeah, we're talking about analytics. Where is it coming from and how do we achieve this descriptive, diagnostic, predictive, and prescriptive? Again, all starts with data. So in terms of analytics development, what our managers are looking for are graph results, what we need to do. That's what we discuss in the meeting strategy. But the team behind when building the analytics, they must know all of the previous one, starting from the source, which is the data. So the starting point, we have the data, and then the data will be transformed, which we will discuss, and then we will visualize the data. At the end of it will be the business user. The business user who will be making the decision will be gathering insight from those analytics. So let's talk about the first part, which is the data preparation. So let me, again, this is another journey that I'm taking you with me from the data preparation up until the graph later on. All right. So let's talk about data preparation first and foremost. Data, data and data. So data, we have the small data up until this big data. So back then we are so used to only megabytes, kilobytes, gigabytes. That's all we are used to. But when we are talking about big data, the amount of data that we have collected, including the real-time data, it will generate a bunch of data to the point that has actually changed units. So currently we have exabytes, we have petabytes, we have zettabytes. So these new terms are used in the era nowadays to replace because gigabytes are no longer enough. Gigabytes, terabytes, our hard drive or our pen drive are limited up until terabytes. But the data that we're dealing with are actually a lot more than that. So as you can see, for example, yottabyte is equals to 250 trillion of DVD. So we may be used to DVDs, keeping all the, because it's impossible to keep 250 trillion of DVDs physically, right? So now we have terms where we can use the data not only in, we're not longer storing in DVD. So this big data will use this term in order to basically handle the amount of data that we have. Now we talk about the data. So the data is getting bigger, bigger, and bigger, right? So the data that we're talking about, what kind of data? Because we talked earlier, the data is coming from our phone, it's coming from machines. So what exactly are the types of data that is coming in? We can say that it's a lot of data, but what actually are those data? That's where we go for this one, structured and unstructured data. I would like to introduce to you, because what I imagine is that when we talk about data, we are only thinking about Microsoft Excel, for example, or even a database like RDBMS, where it's all in a structured table form. You have the data, you have the ID, you have the location and such. But nowadays, we are no longer limited to structured data. We are also going for the unstructured data. So what is the difference between structured and unstructured data? So structured data will be all the values that can be placed in a table form. You have the text, you have the numbers, you have the percentage. All those data are considered as a structured data. You can put them in a table. All of these data is actually small because they require less space and they are a lot easier to manage, because when we talk about numbers, we have the category number, and we, for example, we talk about names, it's all alphabetical, so it's all a structured data, really simple, rather lightweight. They're not heavy in terms of size storage. So these are actually, and nowadays, no longer our main data. Our main data we receive from all these places are actually unstructured data. So all these unstructured data, images, audios, videos, documents, the emails, and the spreadsheets, all of those are considered unstructured data because we can't put them in a table. So this data cannot be analyzed the same way as a structured data. So it cannot be shown in a rows, columns, or relational database. So it cannot be used with a normal database. These videos, audios, they require a lot more storage. So these videos and audios, they don't have a data for us to look at, because what we will do is we will analyze them. So these types of data are actually a lot more difficult to manage. Okay, so when we talk about all of these data, so we talk about the data is very big. We talk about the fact that it has multiple different types of data, structured and unstructured. So how do we arrange all these types of data? We have different types of data, we have a lot of data, so how do we arrange them? It is important to know this schema of data. So we can no longer use the Excel or RDBMS as we used to back then. The table form that we use is no longer efficient for us to use. We need a different way of structuring and organizing the data in a database. So let's look at the first one. This is the six examples. There's a lot more. The main six I would like to show here is the flat file model. All these terms may be new to some of us. So let me explain a bit. Flat file model is the most simple database. It stores the data in a single table, like a spreadsheet, I would say. A flat file model is flat. So it only stores a simple data. So this data, whatever is whatever it is that we are having, only rows and columns is a 3D data. So this will be useful where the data is not having relationship with many different data. So let me give you an example. It's a small business, one person business. They are only selling one item. There is only one process that they need to do. So that is a very simple data. When we have multiple departments or multiple processes in our business, we cannot use flat file model anymore because we have different departments and the different business processes. Those departments and business processes will generate different types of data. These different type of data cannot be considered simple enough to be in a flat file model. Let's go to the next one, which is the hierarchical model. So this hierarchy, it organizes the data in a tree-like structure where you have the parents and the child, the top and the bottom. And each of these parents can have multiple children. You can imagine a tree, but in this one, it can allow us to go for file systems of organizational structure. So we have organizational structure of data, then we can use the hierarchical model. So these are simply the different types of how data can be arranged, essentially. So network model is, I would say, a more flexible version of a hierarchical model. So this network can be connected in a lot more than just a parent and a child. So you can have the cousins, you can have the aunts. So this network model are a lot more flexible. And when it's flexible, it allows the data to be a lot more complex. For example, you have a supply chain. Supply chain has a lot of different business processes, a lot of different data sources that is coming in for this network model. The most common one is actually the relational model. The relational model is where the data are stored in table form. These data can easily be accessed. So most business applications are usually using relational model. Maybe we can talk about our financial system. We can talk about customer relationship management, CRM. So those are using, majority are using relational model. You can see over here, they have like multiple different table and these tables are connected to each other. A cousin or a sibling of it is actually a star schema. So star schema and relational model is a lot similar, but with a bit of a tweak. So star schema is more optimized for the data warehouse or analytics. So compared to all the others, the star schema and the snowflake schema are actually a lot more suitable for analytics. Why? Because when it comes to data analytics, right, we are not looking at the data row by row because we are looking for pattern. That's all. So for example, we have millions of rows of data. We are not looking at each one. All we want to know is what are the patterns. So star schema and snowflake schema, these ways of arranging the data will enable us to look for patterns much efficient, much more efficient and faster compared to relational model. Because as you can see, the relational model, they have a lot of different tables which if we want to access in order to make um, analytics every single time, it will be very inefficient in terms of cost, resources, and also time. But when we look at star schema and snowflake schema, we can see that one of the table is actually blue, the different highlighted color. Why? Because in analytic processing, we will access only the one table. This one table is connected to many other tables, but the one that we are accessing is the highlighted one. This enables us to be much faster and much more optimized in terms of gathering the data and making an analyzation. So this analyze process will be much faster, much more efficient, and it can achieve a lot more compared to the relational model. So star schema and snowflake schema, they all have tables, but they have the main table, which are the central table that can enable us, this central table are arranged in a way that it has all of the key information. So in relational model, the key informations are segregated to many other tables. But star schema and snowflake schema, the key information in order to make the analysis, it's stored in the main table or the central table. In that way, we can analyze simply based on the central table, which obviously makes it a lot. So if you ask me what's the difference between star and snowflake, I would say that snowflake is much critical or crucial version in compared to star schema. Star schema is a basic structure. If you expand the star schema further, that will become the snowflake schema. Which one to use? Depends on your data. Based on your data, you will know how much complexity are you requiring all this arrangement of data that you have. So let's talk about more about this SQL and NoSQL. So we talked previously about the structured data and unstructured data, right? And you've mentioned that the unstructured data cannot be put in a table, cannot be stored in a table form. It must be stored. All the videos, all the audios, all the documents, it cannot be stored in a table form. That is where the term SQL and NoSQL comes in. So this term is very widely used in the age nowadays when we talk about analytics, because if we are only analyzing structured data, then we will use SQL, where all the data are stored in table form. But if we are looking into unstructured data, we will need to use NoSQL. NoSQL have a lot different ways on how to arrange data and how to access the data, because the size are different, the format are different. All of the different formatting will require different structure in terms of data. So SQL and NoSQL. So if this is a bit too technical, let's go for this slide, which I'm sure you all of us are familiar with at least some of the terms. So maybe we are familiar with the Oracle, maybe we are familiar with SAP, with SQL Azure, or maybe we're familiar with Snowflake. So these are the examples from the SQL and NoSQL technologies that we use. So for example, when it comes to documents, storing documents, the most common one that we use is actually MongoDB. So MongoDB is a type of database that enables us to handle all these documents much more efficiently. So we have the NoSQL and also the SQL, which a lot of us are maybe familiar with Azure SQLite. So these are all the examples for you to be able to relate to. What are some of the examples of SQL and NoSQL? All right. So we have talked about where the data is coming from. We talk about where the data is coming from, what type of data that we have. Now that we have the data, what do we do with it? Regardless if it's structured or unstructured, regardless, we will still need to do the next process, which is the transformation of the data. So we have got all the data. We have a lot of data in our hand, but before we can analyze everything or anything, we need to transform the data. Like we have talked about, the data is so vast. We need to be able to do the best analysis that we can do, to be able to have the correct and accurate analysis. We need to ensure that our data are accurate and correct as well. Okay, so that's where the data transformation comes in. Okay, so in data transformation, let's go a bit deeper on what are the things that we do in data transformation. So data transformation, it will improve our data, better organization. Because when we talk about data, right, we have a lot of different sources coming in, a lot of different types. So all of these data coming in, we need to organize them to be able to make analyzation. So better organization, better data management. Why better data management? Why is it important to have a better data management? Because when it comes to data management, it requires cost. We talk about monetization, right? Monetization after the analytics has been done. But we need to look into the cost during the analysis process. So when we are trying to analyze something, it is a process where we will use the technology and it will require cost. What cost, if you may ask? For example, cloud storage. If you're talking about cloud storage, every single transaction that we make, every single query, every single input of data that we store in the cloud is a cost. They will charge us based on how much and what we do with the data. So that's why we need to have a better data management to ensure that we can access our data in the most optimized way. So we don't have to access in like 3 different steps. We can access in one single step, which will ultimately reduce our costs. It relates back to the monetization that we have. And then improve data quality. Of course, quality will improve, have a direct result to the analytics. Because if you have a garbage and all that came out is garbage, if you have a quality one, and then you get a good quality analytics at the end. And perform faster queries, that is enable us to do the quicker decision and faster decision, more accurate one, and more use out of the data. Simple to say that if we have 10 rows of data with 10 different columns, a very simple data, but these data, we can do transformation with them to be able to extract more knowledge from the data, not just the limitation that we have. So whatever data that is coming into us, we can actually generate more data or more information based on the one that is given to us. We can do via calculation, we can do by pattern recognition. So all of those can generate us more data. More data, why? Because more data, more analytics and more accurate analytics, more in-depth analytics that we can do. So what is data transformation and how do we do this data transformation? Data transformation is a rather technical part that we will discuss, but let's give a brief overview first. Data transformation can also be called as data wrangling. It can also be called as data cleaning. Okay, so it's an internet. We can use interchangeably data wrangling, data cleaning, data transformation. So these data, we will transform them, we will clean them, we will wrangle with them to achieve all of this better organization, better quality, and so on. So looking into data cleaning, right? So when we talk about data cleaning, we have different things that we may do with the data. So you can imagine a bunch of data, millions of rows of data. What we need to first make sure is the data is updated. Because what often happens in organizations that are not digitally transformed yet is that their data are segregated. What is in your PC and your colleague's PC are different. And how are we going to make proper analysis based on different types of data? So we need to ensure that all data are together and they are all up to date with the latest data. You cannot have different version of data. This version on your local PC is different from this version from your colleague's PC. The one that you show your boss is different. So first we need to make sure that the data are all up to date. Next one, we talk about the missing values. So these missing values can happen many different ways. So if we can imagine a machine producing the data, maybe there's something wrong with the connection. So the data when transferring coming to us, something wrong with the connection, it got disrupted. So this part of data, maybe for 2 minutes, it goes down. Where we don't have the data, it's missing. Okay, so this data is gone in the middle and then suddenly it have again. So there is missing values coming from, for example, machine. They also have missing values coming from human. Because when we talk about human, the most common thing is that human error when it comes to data. Human may input wrong numbers. Human may input no numbers at all when it comes to the data because a lot of data that's part of human mistake. So that's where the missing values are coming in. So we will either replace the missing values, we will aggregate the missing values so that these missing values will not interrupt the analysis. So let me tell you, for example, in terms of sale for 1 month is 30 days, right? And then on the 15th of October, the machine goes down or the person in charge is not there. So the data is not coming in for 1 whole day. The sales are coming in, the sales are ongoing. But on 15th, the data is not being keyed in by the machine or by human. So on the 15th, missing values. It looks like if we do analysis with this problematic data with missing values, the pattern that the analysis will pick up is that, oh, on 15 we have less sale or we have zero sale. Actually, that's not the real information, right? Because the sale is happening, it's just that the data is missing. So we need to ensure that did not happen so that our pattern recognition later is working, making assumption based on the correct data. So that is the missing value. And we also have duplicates. Duplicates is very, very common. So when it comes to duplication, we have different kinds of data that are repeatable, data that are unique. So for example, as we all know, Malaysian, we have our my card IC number. So IC number, those are unique. Our passport number, those are unique. Our names, are they unique? No, there are a lot more people with similar names as ours. So in terms of duplication, we need to ensure that the unique data are not being duplicated because it will cause issue when it comes to analysis. All this duplication of data we need to ensure so that, for example, on the 15th of October again, 15th of October, if it has so many different types of data and then there's duplication, it will may think that we have like double the sale on 15th, which is wrong. So we also have numerical outliers. Next up, numerical outliers is, for example, we have temperature. The temperature of the factory ranges from 18 degrees Celsius up until 40 degrees Celsius. It's hot. And suddenly we have numerical outlier coming in with 400 degrees Celsius, which is impossible for the factory to be at that temperature. So we consider that as an outlier for us to get rid of. And then we can check our ID. We can also define the valid input. So again, for example, a valid input such as our phone number. Our phone number are data. So this phone number, if someone is keying in alphabetic ABC into our phone number section, then it will be considered invalid input. So that's where we have the valid and invalid input. Moving forward, once the data is already being cleaned, we can do visualization. Once we have already the data that is clean, we can proceed with visualization. This is the fun part. This is the fun part where we are creating the dashboard. We are creating the analysis that we want to do, right? Okay, so big data and analytics visualization. So when we talk about data visualization, there is so many different types of visualization. So different types of visualization is suitable for different types of data and suitable for different types of analysis. So there's a few that I would like to introduce. Simple ones I would like to introduce today. The first one would be the comparison. So based on our experience in the industry is that whenever we go to the industry and we talk to the client, what kind of analysis are you doing? Oh, we are doing analysis. L- Can you show us the graph that you're doing this analysis with? Majority of the time, they're coming up with pie chart and pie chart only. So some of the clients, they do love their pie chart. The thing is, pie chart is good for some data, not all data. Pie chart is a very simplistic and very minimal representation of what the data is actually showing. So we need to have more. So let's go. For the first one, we have comparison. Bar chart, I'm sure we are all used to that one. We have also the line chart. Let me just go through some of it. All of these different charts we can do, for example, when we know that we want to do comparison, we can use the bar chart, we can use the line chart, we can use the bubble chart, the stack bar chart. So what we want to advocate is in terms of data literacy. Data literacy means that you know your data and you know how to tell a story out of your data. So how do we tell a story from our data? It's by using all this visualization. So to give the best story representation of the data, we need to know all of these different types and when and how to use them. So there are a lot. What we are showing here are just some samples of what these different types of data can do. So simplest one, I would say the singles, like the rightmost, where we have the card and gauge. These are showing one or two data, the maximum. And we have the more complex one where we talk about the correlation, we talk about the distribution, all these different types of data. If you are saying that your organization is data literate, have the data literacy level, intermediate to advanced, then all of this data visualization, it should be at your fingertips. We should be able to name all of this visualization and we should be able to know when and where to use all of this visualization and how to read them. The how to read them is usually what people, they know how to create the graph, but once the graph is created, how to read the data, how to read the graph to gain the insight that we are looking for. All these different types of data can be explained here. So let me start a bit. Maybe give you maybe like 10 different examples of this data visualization. This is to improve our data literacy. So let's start with the bar chart. When we look at something, we must always know what they are, when to use them, and why exactly are we using them. So the pros of this bar chart is to display large amount of data without it being cluttered. So when we have, for example, you can imagine a pie chart. A pie chart, if you have 10, if you divide the pie chart into 5 different sections, that is bearable. So you have the different sections of the pie. You split the pie into 5 different sections. That is bearable. But what if you have 10? What if you have 15? What if you have 100? So the pie, if you're trying to split them into 100 different sections, you can't eat the pie anymore. The pie will not look like a pie anymore. It does not have the info. It cannot give you the information properly because the pie has been segregated too much. Too much section. We cannot even identify what is which anymore. So that is where we can use the bar chart, for example. This is used to show in terms of the category, all the data that is needs to be categorized. Course bar chart, it can be horizontal, vertical to us. So next part is in terms of the line chart. So line chart, the first thing that comes to our mind is all the data may be in a timeline. So when we're talking about data, it's continuous. It can be from the month of January until the month of December. All of the data are continuous. It's not categorical. So this continuous data day by day, the timeline that we have, it is suitable using a line chart. So it can be showing us the fastest way for the trends. So this is a very great way to simplify the complex data. For example, we have 10 years of data. So those 10 years can be simplified into this line chart. Let's talk about the next one, which is the popular one, which is the pie chart. So pie chart is definitely a very appealing and aesthetically pleasing chart. So it's not too complex. It's easy for our eyes to see, but it is definitely, as I mentioned, limited in terms of what it can effectively display. So if you use a pie chart, of course, you can separate them into 100 different categories, but it won't be efficient. If the pie is being split too much, then you won't look like a pie anymore. You won't be able to get information out of it. You won't be able to analyze them. So this pie chart is good if you have less amount of category of less data you want to show. So in this case, there are limitations to it. We can say the percentages of what a value is. So maybe it's 50%, and such. So this proportion, we can see which one is having more proportion compared to the others. That is in terms of pie chart. I would say in terms of best practice, let's not go more than 5 maximum. Usually, 3 is the best practice to split the pie, but maybe we can make it up to 5, but that's all. Anything more than 5, best to find a different graph for us to see. Next up, we have the area graph. Area graph is a combination of a line chart and also a bar chart. So these values, the numerical values that we have, are dependent upon the variables that we have. So this area graph will provide us more dimension, more depth into the data. So we are not comparing only one or two. We are not only comparing one or two information, we are comparing more elements from the data. So we can compare more, meaning we can have a better understanding of how these data interact with each other. So for example, if we talk about sale, how is the public holiday affecting our sale? How is the day, time? Is it morning? Is it night? How is it affecting our sale? Right? In terms of sale, which platform is providing most, contributing most to our sale? So all of these elements will affect our sale. So what we can use is the graph to see how these elements interact, how all these features interact with our data. So that is a brief into the area. Let's move on to the map. So as we've talked about before, we have a lot of different types of data. Let's see map. Map is my favorite way of showing how a certain geographical data is contributing to our information. For example, let's talk again about sales. If sales is happening heavily more on one side of the country, for example, it's happening in the West Coast a lot more. So we can identify, we can analyze why West Coast has a lot more sales compared to the East Coast. And we can, based on the analysis, we can, for example, using the map, we can zoom in to all of these states and we can zoom into all these region within the state to be able to identify what is the most contributor, which one is the bad part, which one is the good part, and contributing to what we are looking for. That is a map. And map not only limited to Malaysia, of course, it's worldwide, so the global. This is very useful if we want to have a high level view and we want to zoom in based on the geographic information. Next up, we have the tree map. So tree map, some of us may be used to it, maybe not. So in terms of tree map, right, we have a tree map as a alternative for pie chart. Because in pie chart, like I mentioned, let's just give it maximum 5 segregations of the data. But when we talk about tree map, this particular map, it will enable us to show many different categories. So we are not limited only to 5. We can show more in this tree map. Okay. So in this tree map, it's categorical data, the sizing. For example, we can see in this one, the green one, the sizing will represent the numerical, like the amount of data. So the bigger it is, the larger our data are. So that is in terms of tree map. I would say it's a better cousin of a pie chart. All right. Last but not least, let's go for two, the two other data visualization. So we have the gauge. Usually we have the gauge when we have our target. So the gauge, well, we can imagine the gauge is going towards they have the minimum number and they have the maximum number. And you can see the gauge line over there. That is what our target. So using gauge, we can easily see if it's exceeding our target or going under our target or if it's achieving our target. And we can also see what are the maximum value that we are looking for in terms of the data. So that is the gauge. And we talk also about the decomposition tree. You still remember we talked about the root cause analysis previously. Root cause analysis where we ask why, and why, and all of this will result in the identifying of the problem. One of the ways that we can do root cause analysis is using the decomposition tree. This decomposition tree will go from the beginning and we basically decompose them, go deeper, deeper. It's a tree, right? So we'll go deeper and deeper into the root of the problem. So starting from the left side, we have the main problem. We identify all of the reasons why it happened. And of course, when we have, for example, 5 reasons, there will always be a main reason. Oh, main reason is this one. This is causing the most issues compared to the other 4. So we zoom in into this one. So we zoom in into this one, go deeper into why this one happened. Why this one happened. So why this happened? We can list out another 10 reasons. So out of all these 10 reasons why this cause happened, we can zoom in further. Out of these 10, which one is the most affecting one? That one, we zoom in further up until we reach the point that there is nothing causing this. This is the problem that we need to fix. Once we are able to fix the reason we want to do root cause analysis is because if we are using root cause analysis, then the information that we have is more targeted, and then we have the high level view as well as the detailed view as why something happens. So once we go into the most effective one, like the root cause, one root cause that we can find, if we manage to fix this one, all of the other symptoms, like I mentioned, all of the other symptoms will be able to fade out because all of it actually goes back to one and only one problem. So we are not facing the solution to 10 different problems. We are actually solving one problem that is affecting all the other symptoms. So having a root cause analysis, for example, using the decomposition tree would be a very, very good way. So those are the phases when we talked about the up until how we can visualize them. So when we want to be able to visualize them, we have all that we need. We talk about data preparation, we talk about data transformation, we already talked about data visualization. So far, what we have talked about are the basic journey of this analytic development. So where it's coming from, what's going on, and what it will be the outcome, the visualization. So out of all of this, we need to have the more elements of what are the technologies, what are the advanced analytics, and how we can achieve the advanced analytics. So the basic parts are done. Now we will talk more about the technologies. Okay, so in that regard, I will pass over to Miss Nadia for more information regarding technologies of this. Thank you.
Thank you so much, Miss Anati. There was such an enlightening session on data analytics development, a very comprehensive explanations regarding data transformation and visualization. Your expertise on this topic has given us very valuable perspectives on its development and also implementation, though it was just a surface for this webinar. Moving on to our second speaker, Ms. Oi Hui Shen, who serves as data scientist at Datalytica Sdn Bhd. Her role as a data scientist showcases her expertise in leveraging data to drive meaningful insights and contribute to the transformative world of Industry 4.0. Ms. Hushan's skill set is a testament to her proficiency in key areas essential for her role. Today, Ms. Hushan will guide us through data and AI technology stack and AI and its types. Therefore, I would like to invite Ms. Huishan to lead us through their presentation on the next session of this webinar. Please take it away.
Thank you, Ms. Nada. Everyone can hear my voice? Everyone can hear my voice. So
Your
good
voice is
afternoon.
quite slow, Miss Hushan.
Yes.
Maybe you can speak a bit louder for the audience to hear.
Okay, thank you for your response and speak. Okay. Good afternoon, everyone. Is it okay? Okay.
Okay, Hushan.
Okay. So my name is Huishan, and today I would like to share the information on the data and AI technology stack and introduction of AI as well as the type of AIs. So now we look into the what are the technology used. So let's look into the data technology stack. The data technology stack architecture is an integrated system that enables organizations to gather, process, analyze, and utilize data effectively. It typically consists of 6 core components, each of specific technology and tools that work together to deliver value from raw data to actionable insights. The exact structure may vary depending on the organization needs, with some components being served by multiple tools or technologies. First, we look into the data source. The data source are the ingredients of your data, and they can be very extensive, including database, applications, and device. These sources include database, such as event streams. The database store structured data, which is SQL database, or unstructured data, NoSQL database. For example, a streaming platform might use relational database for user data, such as the PostgreSQL, and NoSQL for reduced files, such as using the MongoDB. For the SaaS apps, is the customer and operational data are commonly stored in SaaS tools like Salesforce, which is the customer data, or Zendesk supports tickets. For the last one is the event streams. Events are log user interaction, such as website clicks or IoT sensor data, sent for real-time analysis using technology like Kafka. Let's look into the type of database. We go through for this slide. So it has 3 type of database, which is the relational or SQL database, time series database, NoSQL database. For the SQL database or relational database, the data is organized in tables, which is the row and columns, and relationship between data are defined using the keys. This structure ensures data integrity. It uses structured query language SQL for operation like insert, querying, update, and delete the data. The SQL database ensure atomicity, consistency, isolation, and durability, making them reliable for transaction. The example of the application database in this category is MySQL, Oracle, Microsoft SQL Server, PostgreSQL. The next one is the time series database, which is designed to handle data points indexed by time, focusing on tracking change over intervals, such as the sensor data, financial market data, or server metrics. It optimized for reading and writing large volumes of timestamp data, ensuring quick access to recent data and efficient storage. The database can use in this category is InfluxDB, TimescaleDB, Graphite, and the Prometheus. The last one is the NoSQL database, which is the flexible schema allowing storage of unstructured, semi-unstructured, semi-structured or structured data. They come in different types, which is the document-based, key value based, column family, and graph database, which have shown previous the slide by the Miss Anati. This The horizontal scalable server for large data sets and distributed systems. It prioritizes consistency, availability, or partition tolerance. It's depending on the implementation. The example which can use in this NoSQL database is MongoDB, Cassandra, Redis, and Couchbase. Next one. We look into the data integration. This component focuses on collecting data from various sources and moving it to a unified location, typically a data warehouse, where it can be used for analysis. There are two main approaches using here for the data integration, which is the ETL and ELT. ETL, the traditional ETL approach involves getting data from various sources, converting it to convert to a standardized format, and then loading it into a centralized location. For the ELT, where data is first extracted and loaded into the data warehouse, and then transformed directly within the warehouse. Tools like Talent and Apache 9.5 that offer a lot of connector to different data sources, while Apache Kafka and Snowpipe by Snowflake handles real-time data stream. Next, we look into the details for the ETL and ELT. What are the ETL and ELT? The ETL, E stands for extract, T stands for transform, L stands for load. The extract data is extracted from multiple sources in its raw format. The transform is the extracted data is cleaned, normalized, aggregated, and transformed to align with the data warehouse structure. This step may include tasks like data validation, filtering, and conversion. The load is the transformed data is loaded into the data warehouse, making it available for further analysis, while the ELT is extract, load, transform. This process is slightly different from ETL. For this extract, the data is extracted from multiple sources in its raw format, just like ETL. And then the load, it comes to the load first. So the load, the raw unprocessed data is loaded directly into the data warehouse or data lake without any transformation. For the transform, data transformation occurs after loading within the data warehouse or data lake. This step aligns the data with business requirements, often utilizing the processing power of modern data warehouse to perform transformation like filtering, normalization, or aggregation. The key difference is in ELT, transformation happens after loading, leveraging the processing capability of the data warehouse for faster and more flexible data handling. The next one is the data storage. Once the data is integrated, it needs to be stored for analysis. There are two main types of storage solutions. First one is cloud data warehouses, such as Snowflake, BigQuery, or Redshift. This offers scalable, powerful query capabilities and are optimized for structured data. For the data lakes or lakehouse, it's traditionally used for unstructured or semi-structured data. Data lakes store raw data in formats such as image or JSON. A modern trend is the lakehouse architecture, such as the Databricks, which combines the scalability of data lakes with the data management features of warehouse. Next, we look into the more detail of the data warehouse and data lake architecture. So this one is the data warehouse architecture. A data warehouse architecture is a system designed to centralize, integrate, and organize data from various sources to support business intelligence reporting and data analysis. It typically follows a layered approach and consists of the following key components.
First one is the data source, which have the external or operational data. For the operational data, it comes from internal business system, such as CRM, which is the customer relationship management, or ERP, enterprise resource planning, and others transactional databases. For the external data, it includes third-party data from external source like AI API, social media, IoT device, or public available data sets. These diverse data types are typically unstructured data, semi-structured or structured data. Then we come to the data cleaning and transaction phase, which using the ETL tools. Next, we go to the data warehouse. The data warehouse is a centralized repository that stores large volumes of historical and current data. It is designed to support query and analysis efficiently. Data in the warehouse is structured and optimized for read operation, allowing for high performance query and reporting. The data is typically organized in schemas like star schema or snowflake schema, which define how data is stored in relational tables. The metadata inside the data warehouse database, which describe the data in a warehouse, include its source, transformation rules, and schema. It helps in understanding the... Sorry? Just now I heard someone on the mic. Is there any questions? No questions. Okay, I'm continuing. It helps in understanding the structure of the data, maintaining data governance, and enabling self-service BI for users. For the data marks, are subset of the data warehouse created for specific departments or business functions, such as the finance, marketing, HR. These are smaller focused repositories that allow users in specific areas to quickly access relevant data without querying the entire warehouse. Data marks are optimized for faster analysis and reporting for their target user. Then we go for the last point. In the data warehouse architecture, which is the end user access data through business intelligence tools, such as their dashboard, which is the visualization tools using the Power BI or Tableau, and reporting tools that connect to the data warehouse to provide insights. These tools allow non-technical users to create reports, analyze data, and visualize trends without needing deep knowledge of the underlying database. For the report, is predefined reports that summarize key metrics and KPIs for different business functions. The dashboard is the interactive interface that allows real-time data exploration and visualization. The next one is the data lake architecture. Data lake is a centralized repository that allows you to store and manage multiple types of data that are structured, semi-structured, and unstructured. For the structured data, such as the relational data, the table from database. The semi-structured data is the data with some organization properties, such as the JSON, XML, or CSV. The unstructured data is the raw data without a predefined structure, such as the image, videos, text, social media data, and others. The data source also include the database, IoT device, machine logs, APIs, and others. So it's go to the next, which is the injection layer. It is responsible for collecting and bringing the data into the data lake. This includes batch injection, which is periodic injection of large data set, such as the daily uploads of transactional data, transactional data. Next one is the streaming injection, which is the real-time injection of continuous data streams, such as the IoT sensor data, social media feeds.
Again, 6:30 to 8.
Someone on the mic. Okay. Okay, sorry. Okay, let's continue. Whether data ingestion can occur through pipelines, APIs, or connector. The storage layer is the core of the data lake architecture. Here, data is stored in its raw format without any transformation or schema enforcement. The next one is the scalable storage, which is a cloud platform like Amazon S3, Microsoft Azure Data Lake, and Google Cloud Storage are often used for the data lakes due to their scalability. It also have the data trace include, which have the raw zone, clean zone, curated zone, the raw zone, which is store the raw unprocessed data as it is digested, the clean zones, which after initial data processing, for the cleaning and transformation, the data is moved here. For the curated zone, which is fully processed and structured data ready for advanced analytics or reporting. Then it performs the ELT or ETL for the processing, and then it goes for the data mart and or the real-time database, and then show the visualization as like the previous data warehouse architecture, and it's also can go through the data preparation and validation, and then use the machine learning and data science the technology to show the data. The next one is the data transformation, which is the process of cleaning and preparing raw data for analysis. This step is crucial as it ensures that the data is consistent and usable. Some common transformations include cleaning, which is removing duplicates or incorrect data entries. And also for the filtering and joining, combining data from multiple sources for consistencies. Tools like DPT allows data professionals to transform data post-load in the ELT process, simplifying the transformation process within the warehouse. Next one, we go for the data use. The ultimate goal of a data stack is to make data useful. There are two primary use cases, which is the business intelligence and analytics and data science and machine learning. Tools like the Tableau and Power BI allows teams to build dashboards and generate insight from data in the business intelligence. And then for the data science, tools such as the scikit-learn, TensorFlow, and Jupyter Notebooks, and also the data robot enable teams to develop predictive models for decision making. This includes building machine learning models and automatic tasks based on the data insights. So this is a sample employee performance dashboard showcasing various types of visualization to effectively track and analyze key performance metrics. This is an example for the dashboard in this one, data use, BI and data analytics. Next one is about the data governance, orchestration, and monitoring. The data governance is a critical part of the modern data stack because it ensures that data is managed according to established process, policies, and regulations. It covers several key areas, including data privacy and security, data quality, compliance. For the data data privacy and security, which is ensure sensitive data is protected against unauthorized access and breaches. For the data quality, it maintains the accuracy, completeness, and reliability of data. For the compliance, it aligns with industry regulations like GDPR, HIPAA, or internal organization standards to avoid legal and financial penalties. For the effective data governance involves a multidisciplinary teams responsible for defining and enforcing rules around data usage, storage, and access. This team continuously update governance policy to meet evolving regulation and business needs. Tools like informatical cloud data governance, EG, EGNYT, and SAP master data governance. This helps automate this process by enabling auditing, monitoring, and the implementation of governance policy across the data lifestyle. For the next one, the last one, which is the data versioning. The data versioning is the process of tracking change to data as it moves through different stages of the data pipeline, similar to how version control is used in software development. Here is the example of the data versioning. Okay, for the next one, we go for the AI and its stack. Let's go for the introduction of AI. The AI, which is the artificial intelligence, encompasses a variety of definitions and interpretations. The AI refers to the simulation of human intelligence processed by machines, particularly computer systems. It involves tasks such as reasoning, learning, problem solving, perception, and language understanding. And then for the machine learning, is a subset of AI that's focused on the development of algorithms that enable computers to learn from and make prediction or decisions based on the data without being explicitly programmed. It includes techniques like supervised learning, unsupervised learning, and reinforced learning. And then for the deep learning, it's a specialized form of machine learning that involves neural networks with many layers. So it have the terms means the deep. These networks can learn intricate patterns in large amounts of data, leading to significant breakthroughs in areas like image recognition, natural language processing, and autonomous vehicles. But the next one is the foundation models, which are the large-scale AI models pre-trained on vast amounts of text data, enabling them to understand and generate human-like language. These models serve as the basics for various AI applications, including natural language understanding, text generation, and sentiment analysis. The last one is the generative AI. The generative AI refers to AI system capable of generating new content such as image, text, or music that mimics human creativity. It often involves techniques like generative adversary networks, which is a GAN, and variational autoencoders VAE, which enable the creation of realistic and diverse outputs. Let us go deeply with the introduction of machine learning and deep learning. From this slide, we can see the difference between the machine learning and deep learning. For the machine learning, we can see in the image under the machine learning, which is machine learning use algorithm and learns on its own, but may need human intervention to correct errors. For the input, which is the raw data such as the image, text, or numerical data. And then for the future extraction, which is manually extracting relevant features or attributes from the data, such as the edge detection in image. For the classification, we can use the different algorithms, different machine learning algorithms, such as the decision tree, support vector machine, random forest, and others to classify data based on extracted features. Last one is the output. Predicted labels or values, such as the identifying whether an email is spam or not. This one is the output, which is give us the classification. And then for the example of machine learning is spam email detection, recommendation system, and predictive analytics. Next one is the deep learning, which uses the advanced computing and its own neural network to adapt with little to no human interventions. The input, also same like the machine learning, is the raw data such as the image or the text. And then go to the neural networks, which automatically learn features through multiple layers of interconnected nodes or the neurons in a neural network, enabling the model to learn complex patterns. And then it's go for the output, which is the predicted labels or values similar to traditional machine learning, but with potentially more understanding and accuracy due to automatic feature learning. For the example of deep learning is image and speech recognition, autonomous driving, and language translation, and others. And then you can see here for the tables are the difference between machine learning and deep learning. You can see based on these factors, the data size, requirements, accuracy, solve problems, training time, hardware dependency, hyperparameter tuning. You can see the machine learning, right? For the data size is small and deep learning is large. And accuracy is less for machine learning and high for deep learning. And you can see the advantage and disadvantage for the machine learning and deep learning. You can see it using the short training time for the machine learning and used for the deep learning long training time. And machine learning use the explicit programming and the deep learning based on the neural networks layers, and it requires GPU for the long training time, and the machine learning just can use the CPU because have the smaller data set. And the hyperparameter trainings for the machine learning limited training capabilities, and deep learning can be trained in various different ways. They have a lot of different ways for the hyperparameter in the deep learning. Okay, for the next one, we can see for the type of machine learning. It has the supervised learning, unsupervised learning, reinforcement learning. In the supervised learning, it has the classification and regressions. So the supervised learning is a type of machine learning where the model is trained on a labeled dataset, which means that each training example is paired with an output label. The goal is for the model to learn the mapping from inputs to outputs so it can make accurate prediction on new or unseen data. The classification, this involves predicting categorical labels, for example, classifying the emails like spam or no spam based on their content. The example of application are identify fraud detection, image classification, and customer retentions. And then for the regression, this involves predicting continuous values. For example, predicting house price based on features like size, location, and number of rooms. The example of application population growth prediction, estimating life expectancy, market forecasting, weather forecasting, and advertising popularity prediction. The unsupervised learning is where the model is trained on unlabeled data, meaning the data does not have predefined output labels. The goal is to identify patterns, structure, or relationship within the data. It has the dimensionality reduction, which is involved in the reducing the number of features or variables in the data while retaining as much information as possible. For the clustering, this involves grouping similar data points together based on their features. For example, clustering customer data into segments such as high-value customer or frequent shopper. The example of application are recommender system, targeted marketing, and customer segmentation. The reinforced learning is an agent learns to make decisions by interacting with an environment. The agent performs action and receives feedback in the form of rewards or penalty. The goal is to learn a policy that maximizes cumulative reward over time. We can see each of the application of each type of learning in their colors, which is can see the reinforcement learning application is have the real-time decision, robot navigation, learning task, skill aggregate, and game AI. For the next one, this one is type of AI, type of artificial intelligence. It have two categories. First category is capabilities. So there are three stages in the capability category. First stage is artificial narrow intelligence, ANI, also known as weak AI or general purpose AI, designed to perform a narrow task. They do specific tasks autonomously, which is a limited range of competencies. Even the most complex AI that use machine learning and deep learning to teach itself can fall under the category of ANI. For example, Siri, Alexa, Cortana, and Google Assistant for this category, for this stage. The stage 2 is Artificial General Intelligence, AGI, also known as Strong AI, Full AI, or General AI. It is a system with generalized human cognitive ability. When presented with an unfamiliar task, it can find a solution without human intervention. At this stage, machine intelligence enables the system to understand, learn, and apply knowledge across diverse domains, much like a human. For example, Pillow Help Robots is a prototype automated medication management and voice first smart home healthcare device. It can remind user and dispense medication on a preset schedule. It can also deliver audio or video-based health content and facilitate video calls between patients and their caregivers, while allowing them to monitor the data from the device. Last stage is Artificial Superhuman Intelligence, ASI, also known as the Superhuman AI or Superintelligent AI, which surpasses human intelligence across all fields. ASI is equipped not only with exceptional machine intelligence but also machine consciousness, allowing it to become aware of its environment itself and possible its own decision-making processes. It will be exceedingly better at everything they do because of its greater memory, faster data processing and analysis, and also for the decision-making capabilities. For instance, an AI that can outperform humans in every task imaginable. For currently, technology is under the stage 2 AGI, which can see in the right hand side for the image. next station, I will hand over to Miss Nadia. Thank you, everyone.
Thank you so much, Ms. Uhuishan. There was an insightful exploration of data architectures and the fundamental concepts in artificial intelligence. It was a great overview of the various types of machine learning and AI leveraged in the current era. Last but not least, let's welcome our third and the last speaker of the day. He is Dr. Muhammad Imran Sarwar, an Industry 4.0 evangelist with more than 18 years of experience in digital transformation. He is the CEO of Datalytica Sdn Bhd, specializing in smart manufacturing, smart city, supply chain, construction 4.0. Dr. Imran is also an adjunct associate professor at the Harapi Highcom University and actively contributes to the IEE and ACM communities. Dr. Imran will unravel the mysteries of data architecture assessment, data strategy development, data integration planning, data governance framework design, AI monetization strategy, paving the way for our exploration into the heart of AI's potential. We are honored to have Dr. Imran with us today. The virtual stage is yours.
Can you hear my voice?
Yes, we can hear you, Dr. Imran.
Okay, can you see my screen with the
Yes,
slides?
we can see the slides.
Okay, thank you very much, Ms. Nadia. I would like to extend my sincere thanks to everyone for attending this online webinar. So, Ms. Anati mentioned about the data transformation in terms of descriptive analytics and also visualization. And Ms. Huishan mentioned about the AI, artificial intelligence, and also its technology stack. On my part, basically, we will be looking into how we have combined them towards the organization transformation and also what are the core elements in terms of technical technology consultancy. So our goal in terms of either we are for manufacturing or supply chain or any corporate is to have a lighthouse certification. Lighthouse certifications are from World Economic Forum, who also coined the term Fourth Industrial Revolution, in which we are looking into technology-led, capability-led, and replicate the transformation success story. There are 99% of the organizations have the data, and they are struggling in how to monetize the data. Now, mostly if you are using Excel, you are having a data but in silos. Silos means that you don't have a visibility of those Excel across the team members and also across the organization. So Lighthouse Factory are basically a way for you to inspire from the success stories of other organizations and also benchmark where you are and where you should be. So in terms of digital transformation landscape, uh, we need to look into end-to-end ecosystem in terms of analytics and monetization. So in order to understand the data and then transform it, you need to have some upskilling or skill development program, especially in terms of Industry 4.0. Now, previously, we were looking into data literacy as a base skills for everyone. Now we are looking into how we can able to have a AI skills for everyone. So Industry 3.0, in Industry 3.0, we were having a notion where IT was helping in terms of end-to-end transformation. So IT was a core team, but at the same time introduce a bottleneck where Industry 4.0, it is data driven, so everyone needs to understand their transformation where IT is just a core enabler or a facilitator. So Industry 4.0 transformation skills, especially in terms of descriptive and diagnostic analytics using Power BI and Python for advanced analytics is a baseline for everyone to learn in order to have a monetization of the data and AI. Number two is on the organization level maturity assessment in terms of people, data driven process. E2E means end to end technology, data transformation, and also strategy and implementation roadmap. After that, you need to gather, aggregate, or add those data from different sources. If you are in a data silos in the form of Excel, you need to break the silos to combine and aggregate that data and then do the data management, have an architecture in terms of governance to proceed with the descriptive diagnostic analytics and predictive analytics using an AI stack. After that, for organization level transformation, you need to look into the certification of your organization, agile transformation culture, ESG, and so on. And then R&D is part of it. So in Malaysia, there are a lot of research grants specific not only for the universities, but also for the industry. And this is a way for you to collaborate with universities in a research grant like FRGS or PRGS under Ministry of Education. So industry and academic can able to collaborate in terms of um, innovation. What are the problems right now that can be uh, solved using research grant, and then at the end to create a application from IoT until AI. So that is a digital transformation landscape for any organization, whether they are from manufacturing, corporate, logistics, supply chain. And when we talk about those organization transformation pillar, data is everywhere, and that needs to be used for digital transformation journey. And also how you can transform your people who can understand the language of the data and create a monetization out of it through analytics, which is can be descriptive, diagnostic, predictive, or prescriptive. So we have discussed just now on the maturity assessment, but how about converting the manual process into data-driven industrial process and also technology transformation? And then how we can able to look into those analytics to have a governance. And agile is important not only to break the silos of the data, but also the cross-functional team within an organization. So there will be no silos in terms of teams and department. And those data that will be exchanged within those departments can be leveraged into data-driven process, center of excellence, and also AI solution with a term called RODI. So when you are implementing a technology, you are not looking return of investment, but return of digital investment, which is in the form of RODI, to achieve an operational excellence. That operational excellence using data and AI will help you to reduce your operational cost and also looking into fostering a culture in terms of continuous improvement and efficiency and also reduce the waste, not in terms of materials, but also in terms of time and resources. And finally, ESG is basically quite important. I was yesterday in a conference, ESG conference by Ministry of Economics, in which they have aligned with the UN SDG goals. There are 17 SDG goals that are mapped with the ESG uh, for the ecosystem of technology, sustainability, growth, compliance, and long-term value creation by reducing the blueprint of carbon and also collaboration in this regard. So when we talk about data analytics, we need to go one step back in terms of maturity assessment. In the maturity assessment, we need to look into who are the stakeholders who own the data ownership. Previously in Industry 3.0, data was being owned by IT, but Industry 4.0, it is being co-owned by the system, stakeholder department itself. And then what are the technology that you are using for data warehouse, data data infrastructure, and then also artificial intelligence. And do you have the right skills? You need to review whether you have a skill competency matrix in which you can able to know whether you or your organization have those required skills that is used for data analytics and maturity and also AI monetization in this regard, and also cultural assessment. So we usually do the maturity assessment in terms of people, process, technology, and data. But in here, basically, we are in here we are basically also looking into the organization aspect of managing that data, because people are part of a process use technology, and technology is producing the data that can later on create a value using artificial intelligence used as a catalyst. Hushan and Nati have worked and explained to you about uh, basically four type of analytics. By having those analytics, you can able to have an integration and co-creation value creation in terms of scalable infrastructure, enhanced decision making, because we are shifting from I think this thing can happen, I think that thing can happen, I think which that model can able to work, towards data thing. Data is thinking through AI. So when you have a data itself, then you are looking into aspect of how you can do the monetization. So enhancement of those decision making is an integral part which is can be created and used using analytics. And then streamline data integration. So you have a different data residing in different teams, different department. You break the silos, put those data in the data lake or data warehouse before you create a monetization out of it. Apart from that, how you can improve the data governance and increase your return of investment, and also pathways towards AI ecosystem. You cannot have advanced analytics like descriptive and predictive and prescriptive unless you have analytics which is descriptive and diagnostics. So this is the roadmap. This is the roadmap that you can able to use for your AI monetization. So you can able to have a business objective alignment, and also you can able to look into what is your current state, where have a setup for the data governance, also look into data quality and standardization. Many of the organizations that I have come across, they have an issue in terms of data standardization, where, for example, date, they may have a branch in US, in Malaysia, Thailand, Indonesia. They're using different kind of a date format. So we need to have a data governance and standardization to place into. And when you want to scale the data, you need a server or cloud. So you need to make sure that your data infrastructure support data lake, ETL pipeline or ELT pipeline, data warehouse, and also data mart. Those infrastructure will able to help you in terms of categorization of the data, in terms of how refined they are, how value oriented they are, and who is the ownership of having those data. And then apart from that, you will look into the data security at rest, which is called data at rest, how you can secure the data, and also look into the descriptive analytics deployment, diagnostic analytics and root cause, and also predictive analytics development towards the AI transformation, and also for the change management. You can start with your team, individual team, and from those team you can able to proceed with the department, and from those department you can able to look into your organization level uh, roadmap journey to look into. You can use any of the tools, any of the AI stack that you can able, which is favored for you or your IT is recommending. But this is a generic roadmap that we are using for your transformation of data analytics and also for AI monetization roadmap in an organization. In terms of skills, you cannot able to monetize AI unless you are equipped with those skills that is required for your analytics and AI journey. Now, when you talk about transformation, there can be a leadership level trainings, upskilling, awareness level, for example, IoT, cybersecurity, augmented reality, and also essential level. To me, one of the most advanced and essential level is your Python programming. You can have a descriptive and diagnostic analytics using Power BI, Spotfire, or any other tool. But for your advanced analytics that require artificial intelligence, I think Python is a good way because Python is a prerequisite for some of the key pathways in terms of specialization. So those pathways will help you unlocking your continuous improvement with AI. And one important aspect to look into is this that Python programming forms the prerequisite and also basis for any role that you will be involved in the transformation of your organization in terms of data driven process and AI. That can be data scientists. So in the data scientist, you can able to have a data analytics, you can have a descriptive analytics, and you can have a data science with the capstone project. Number two is on AIoT engineer, which is a combination of IoT and artificial intelligence. And then also looking into IoT, AIoT engineering, and also deep learning. In terms of AI engineer, we are looking into the machine learning and deep learning landscape, where in deep learning, you're looking into CNN, RNN, faster RNN, and also transformers, and even beyond that. And then for data engineering, definitely data pipeline. In those pipeline, you are looking into data transformation before you are using those data in terms of your transformation analytics platform. And then also creating a big data analytics using Spark and also for real-time data operations. Same goes for cloud, DevOps, and AR engineering. So baseline is Python programming in those aspect of the things. So towards your data analytics and also AI monetization journey, you must need to look into an organization for the COE, which is Center of Excellence. That requires you to have a digital development for the digital transformation journey strategy. What are the AI use cases that you can able to implement? And then also categorize them in terms of conventional, standard, niche, or disruptive. And lastly, how you can prioritize based on the end value creation. That end value creation needs to be measured in terms of percentage, which is ROI or RODI. Later on, you will look into the AI maturity assessment in the Center of Excellence, data and AI enterprise architecture, and then also data analytics and governance consultancy. Moreover, AI use case, you need to does not have to implement big. You can have a pilot project or co-creation with the consultant like us and others. Moreover, market research analysis and continuous improvement and experience consultancy is an important aspect to look into towards data management, analytics dashboard, upscaling, and also advisory towards the agile transformation culture. So when we are looking into AI monetization, Gen AI is helping us a lot on the things much more faster. So there are many use cases across different industrial sectors. For example, over here, in terms of manufacturing, you can use Gen AI in terms of material movement, predictive maintenance and machinery inspection, production planning, revenue estimation, and quality control. In terms of retail and commerce, you can use Gen AI with enormous data trained in terms of recommendation, also price optimization and virtual assistants. So Gen AI is quite rapidly growing. It has its limitation, but there's a continuous improvement going on. Same goes for transportation, media, entertainment, automotive, and even defense, where you can use Gen AI to have an enhancement. Now, Gen AI itself is a combination of machine learning, deep learning, NLP, and different kind of artificial intelligence together. And when you wanted to run or develop a model like Gen AI, it's very expensive because there's an enormous data is involved. Some of our clients are basically looking into how they can able to have a custom Gen AI based model for your organization level transformation and learning. So, what is the way forward in terms of AI transformation and monetization in this regard? One of the important aspects to look into is the framework for the data governance. So this is one of the framework. There are many. This framework is called DGI, Data Governance Integration Framework, which is looking into many steps. So you have a people and organization stakeholder, which are termed as who. You have a program value, which is why. You have a governance output, processes, and also work program, which is what and how. And you have a beneficiaries, which are whom. And from those one 4W and one H, you can able to have a transformation steps in terms of number one, what is your core mission? What would you like to achieve using data and AI? How data and AI can facilitate you in your mission and vision statement. So in organization, you have a mission and vision statement, but for individual, you also have some visions. What would you like to be in the future? Tomorrow, day after tomorrow, next week, next month, next year? And what are your core values and what is your mission in life? Without mission, there's nothing. So in terms of people and organization, we start with the mission and value. And number two, we identify the stakeholders, which are beneficiaries of those transformation in an organization. They can be products, services, process, capabilities, and asset. And then number three is what are the data products like catalog, definition, and metadata? What are your governance infrastructure in terms of data lake, data pipeline, data warehouse, and data mart? Number four, what are your control checkpoints in the form of notifications, control environment, and process? Number five is accountabilities in the form of oversight models and metrics. Metrics can be your KPIs or can be your OKR. Number six is about decision rights. What are your decision rights? Are they data related decisions? Number seven is on the what are the policies and rules and governance ecosystem that you are having implemented in your organization in terms of data and AI transformation. Number eight is on your process, tools, and communication. Number nine is on your data governance work program, which is focused on the activities with a work stream in terms of focus, scope, and goals, metrics, and funding. And those data metrics and activities can be strategy, data science, data management, risk management, product management, compliance management, policy, standardization, access control, sharing, fitness for the use, and definition. Number 10, the last one is your participants. Who are your big Gs? Decision bodies. There can be your CXO, data governance office, data stewards, and also custodians and beneficiaries. IT is one of the stakeholders, and also the operation excellence team in an organization are also the important stakeholder in this regard. Now, when we talk about those implementation roadmap, and when you are looking into your transformation in terms of people, your team, organization, you first start with a discovery workshop to discover about your stakeholder identification and also what are their problem and have those five design thinking process, which is discovery or empathy. Number two is define. Number three is ideate. Number four is prototype. Number five is test. And then I'm proceeding with that Industry 4.0 maturity assessment and implementation roadmap towards the data consultancy within or outside of your team in terms of descriptive and diagnostic analytics. Then the transformation training, use case prioritization in terms of value creation. So if you have a categorization, normally I have a four categorization. Number one is conventional. Number two is selective. Number three is disruptive. Number four is niche in terms of AI use case category. If it is selective, meaning that it has been implemented in many organizations with a documented high value creation and it is quite common, you don't need to waste your time recreating it, just buy on the shelf. Number two is on the selective. Selective cannot have an impact standalone. They have to implement together with another existing work use case. So selective can be only applicable if you have a disruptive. Disruptive is more on disruption by implementing a new technologies that can change the older ways or brownfield. And number four is on the niche. which is requirement selected. So you need to look into the prioritization based on value creation, investment, timeline, and so on. And at the end is on the AI transformation solution end plan. This is an end-to-end um, landscape in terms of data and AI technology. So you can able to see that they are compute in terms of hardware, in terms of decentralized, serverless, open source, and edge. And then they are artificial intelligence models. Those models can be for large language models, or they can be novel, multimodal, image-based, speech, video, code, healthcare, robotics, and so on. Towards the now those models are being deployed on the edge or on the cloud. Then you have a data and storage where you have a lot of databases and also ingestion mechanism, querying, retrieval, post processing, augmentation, and also analytics, output generation. And then after that, you have a model development and training as a part of your ML ops ecosystem. And lastly, is about the monitoring and observability of your artificial intelligence. So this is the end of my session. And if you have any further questions, you are most welcome to ask in the chat or via talk.
Thank you so much, Dr. Imran, for your enlightening insights into data analytics, also AI monetization strategy. Ladies and gentlemen, as we draw to a close, I want to extend a heartfelt thank you to our esteemed speakers, TS Dr. Muhammad Imran Sarwar, Ms. Nur Anati Bidin, and Ms. Ui Huishan for their invaluable contributions in our webinar today. Before we conclude, we encourage all to fill in the feedback form and also the attendance form that we will provide shortly in the chat section. Once again, on behalf of Datalytica, we would like to thank everyone for your participation in today's webinar. Thank you for making your time despite your busy schedules to join us here this evening. Let us close the ceremony and you may leave the meeting. I wish all of you a pleasant day. Thank you.